Hey, what's up guys? Welcome back to the Mr. Fix-It channel. Today I have an early 2000s Honda Foreman. This is a 450 ES model and it cranks but won't start, and there's a few other issues going on. So let's get into this one. Stay tuned.
I was sitting out there in the shed one evening, not doing too much of nothing, just kind of staring at the wall. And
Alright, so these machines are getting quite old now. That's 25-ish years old, and when you pick up a used machine like this, it's hard to know what previous owners have done, to keep this thing going. So what we got here is a crank no start. So we turn the gas on here, and first thing I notice when I turn the key is the cooling fan runs continuously. But before I start this thing, I always want to check the oil, because it would be bad to, run this with no oil in it. So that's got oil, that's good. So we'll go ahead and give this thing a crank and see what happens. So we have to ignore that cooling fan running. So no crank. There is a primer button on the carburetor here, so we'll see if that squirts. That is squirting, so we'll try that. Hit the key again. You see it tried to start. So it seems like it's trying to start, but it just won't run. Let me set you guys on the tripod and I'll try to operate that throttle lever. We'll see if we can't get it to start up that way. Okay, as you can see, it won't start. And as I was trying to start it there, I did notice right down here there's an overflow from the carburetor, and if we look at that, I turn the gas on, so something's going on inside that carburetor. So the gas is just overflowing out through the overflow hose. So let's go ahead and pop this carburetor off and open it up, see what's going on inside there. Now usually if you have a crank no start problem on an old machine with a carburetor, it's usually the carburetor. You can spray some gas down through the air filter and see if it'll try to start. I'll tell you real quick if it's a fuel problem or not. I mean, a lot of the stuff I do here is cleaning carburetors. It seems to be really common, especially with the ethanol fuel that we get today. Yeah, and that's what I see in here. I see kind of looks like if you've ever had tapioca pudding, it looks like a yellow pudding with little jelly balls in it. That's what's in this. I know you probably can't see that. I can try to get you in there. You can see the little tapioca balls in there. More than likely that's got the jets clogged up, so we'll have to clean all that out. That's from that ethanol sitting. So since it was overflowing, I want to inspect this rubber tip on the needle. Make sure it's actually there, it's not ripped off. There's no nicks or cuts or any wear in that. That looks fine. Ooh, it's kind of rusty in there. So I just want to check this slide in the diaphragm, make sure there's no tears or leaks or anything wrong with this. So you just kind of pull on it and stretch it a little bit. If there's a tear or a hole in it, you'll be able to see it once you stretch on it. Don't pull too hard, but stretch it a little bit. Alright, everything looks okay with that. So that pin is quite loose in there. the flow is dropping all the way down and touching the carburetor body. So that could be why it was overflowing. We may have a wrong part in here. Yeah, I don't like how loose that pin is. This may be the issue with the overflowing. So let me dig through some carburetor parts and see if I can find a pin that fits this hole more correctly. Connect that. Turn the gas on. Just give it a few seconds here. Okay, carb is full and there's no signs of overflowing, so that's a good sign. I'm going to turn the gas back off and we'll pull the line off. And I want to check to see if this is squirting. I don't know if you can see that or not, but it is squirting fuel. Okay, so everything on this seems to be fine. We'll put this back on the engine, see if it runs right. Alright, let's see what happens. Gas on. Come on, baby. I'm seeing puffs of gas come back out through the carburetor. I'm wondering if it doesn't have a valve problem going on here. Yeah, it does not want to run. Okay, we might have to dig a little deeper into this. Alright, so I pulled the spark plug out. And it is fouled out pretty good, and I just wanted to see what brand it was, and the only thing that's on it, it says DATC. There's no branding on it. This could be a cheap eBay knockoff spark plug. So what I have to replace it with is an NGK. It's a D7EA. So we'll stick this in there and see if that makes any difference. Alright, see what happens. I am seeing compression gases fly out past the spark plug here. Nope, no change. Alright, so I hooked up an external fuel source, hoping that maybe the gas in the tank was no good. Nope, still no change on fresh gas. So I put my hand on the back of the exhaust to feel the exhaust coming out, and it feels normal for it, you know, to be idling or, you know, whatever it's doing. It feels, I don't think the exhaust is clogged. It's possible that the cam decompressor is stuck and it's not releasing the decompressor when the engine starts up, and it's causing a low compression problem. That's only a theory at this point. I would have to disassemble the engine, pull the cam out to inspect that to see if that's actually what's going on. So it's kind of acting like the exhaust might be plugged, which that's really rare for that to happen. Or there's something going wrong with the valves or camshaft. So I'm going to go ahead and pop the valve cover off here and have a look inside. So I'm going to pull the ripcord and try to get this on top dead center here. Alright, there's the exhaust valve opening. There's the intake valve opening. Looks like there's plenty of lash there. Interesting. Just pushing on the valve springs here. I was thinking that maybe one of the valves are being held open, but that don't seem to be the issue. All right, I'm gonna take off the spark plug and crank it. I want to watch the valves move, see if there is something wrong with the camshaft maybe. No, looks like the valves are opening and closing correctly. Could it be the exhaust is plugged up? Someone has put an aftermarket exhaust on this. You know, a slip-on from here back. Let me do a compression test. Put this valve cover back on and get my compression gauge. Let's watch the spark here. Looks like it's got consistent spark. Alright, let me grab the compression gauge. Alright, see what we got as far as compression. So just for reference, that's 125 psi right there in the center top of the gauge. Uh-oh. Barely 80 pounds of compression. I did see quite a bit of crankcase gases coming out. It's possible this thing needs rings, piston. Alright, one way to see if it's the rings or the valves is we can put like a teaspoon of oil down in the cylinder through the spark plug hole, which I've got in this bottle, just some 1030. And if it's the rings, this will coat the rings and the compression should come up significantly. If it's valves, it shouldn't change much at all. It didn't come up very significantly. 90, 89 pounds. Try putting a little bit more oil in there. You don't want to put too much because then you're just going to hydrolock the engine. And another thing, if the exhaust is plugged, the compression is going to be low because if the air can't get out, then the air can't get in. Yeah, we're up to almost 100 now. So what we got here is a case of low compression. Alright, so I've been messing around with this thing for a little bit and I'm starting to come to the conclusion that maybe the timing chain jumped. Like you know, the engine rotated and the camshaft didn't for just a little bit, and the camshaft is actually not opening and closing when it's supposed to. That's very uncommon. So in order to do that, I got to take out the wheel wells. There's a front drive shaft, and drain the oil and get this front cover off where the camshaft lives down in there. That's quite a bit of work. So I'm gonna try popping that valve cover off again and see if I can determine if that's the case before I start digging really deep into this engine. So I guess let me pop that valve cover back off. I gotta find top dead center and rotate the engine over and see if the valves are actually opening too late. So that's the route I'm going to go right now. Alright, so what I'm doing here is I've got a long screwdriver down through the spark plug hole, touching the top of the piston. I'm going to pull the pull start and I'm going to rotate the engine over, and what I'm looking for here is that the valve is opening at the wrong time. Now if it's only jumped a tooth or two, that would be enough to make it where it won't run, but it's going to be really hard to tell if that's the case using this method. So I'm just going to give this thing a few slow pulls and watch the valves and watch the screwdriver go up and down. Now ideally what should happen here is the exhaust valve should start to open when the piston starts coming up from the compression stroke. And then when it reaches, piston reaches top dead center, the exhaust valve should close, the intake valve should start to open just as the piston descends. That'll be the intake stroke, and in the next stroke, at the bottom, the intake valve should be completely closed and the piston should come up on the compression stroke and go back down with both valves closed, and repeat that process. So you see where we're at here in this cycle. Okay, piston's coming up, going back down. That's the compression stroke. So piston's going back down, almost to the bottom. Piston's all the way down. Now the exhaust valve should be opening right now. No, piston's still going down a little bit. Once we reach bottom dead center, the exhaust valve should start open on the way up. Okay, the exhaust valve is starting to open now and the piston's not on its way back up. So the piston's still at bottom dead center and the exhaust valve is starting to open. Now the piston's on its way back up and the exhaust valve is almost all the way on top of the lobe. So it looks like we have valve timing issue. Now the downside to this, using this method, is that if the chain only jumped a tooth or two, it's going to be really hard to tell. And it is kind of hard to tell using this method. The only for sure way is to line up the timing marks, take that cover off, and see if the camshaft is in the proper location. But unfortunately, on this particular engine, this particular machine, that's quite a bit of work to get that off. I mean, you got to take, the plastics off. You got to take the front drive shaft out, take all them screws out of the front cover. There's an electrical connector. There's an electric motor. I mean, what I'm saying here is there's quite a bit to do just to check to see if the cam's still in time. It's not like an overhead cam engine where you just pop the valve cover off and look. Okay, so it's looking like I'm gonna have to pull the front of this thing apart and see if the marks line up. Because I mean, we've checked all the other bases. We've tried a different spark plug. We've tried different fuel. We've done a compression test. We've cleaned the carburetor. Still won't run. Tries to run. And yet again, if the timing has only jumped a tooth, maybe two, it may try to run, it just won't run. If it had jumped 3 or 4 teeth, then it won't even try to start. So, okay, here we go. We're diving deep. Alright, so I took all the plastic body pieces off the front of this. And we can see this cover that's got to be removed. I don't think the drive shaft has to come out. Maybe that motor's got to come out. I'm going to have to go look at the book and see what all this entails, if any of this has to come off. There's a couple oil lines over there and several bolts. So there's these oil lines. Looks like the oil filter's here too. Yeah, I'm not sure about this motor, but at least we're down to it. Let's see what we're getting into here. It's pretty dirty. I think I'm gonna get my shop vac, clean some of this up in here, blow the dust off so nothing gets inside the motor. So let me do that real quick and then we'll see what we got to do. Alright, I think I'm going to start with taking the skid plate off here and get the oil drained out. Now you don't have to take the skid plate off to drain the oil, but I need to take the skid plate off because I want to check that fan switch You got to take this off to get to that, so that's why I'm taking this off, just to be clear. Yep, I had to do the old in and out with that bolt, but she came out. That skid plate's seen better days. Let's see, we got a 19 millimeter. Nope, it's a 17. So we'll let that drain out, and then I'm going to go over there and drain the oil out of the oil filter housing and get those oil lines disconnected. I'm going to get this oil filter off here. Looks like 8 millimeter. Alright, snatch these oil lines off. Let's get this unplugged. Get this out of the way. Now, the manual does say you have to remove that front drive shaft. I'm gonna attempt to do it without removing it. We'll see if it comes off of there. It also says you need to remove the shifter motor. So I'm gonna go ahead and remove the shifter motor now. Alright, in spite of what the manual says, taking that drive shaft out, I'm going to try to take this cover off without removing that. It also says to take that shifter motor out. We'll find out why you have to take these things apart, but I'm going to try to take this cover off without removing those items. So there's a ring of bolts all the way around this cover. So I'm going to go ahead and get removing these, and we'll just see what it takes to get this all apart. Alright, so there's one 8 millimeter bolt down underneath this motor, and the rest of them are just the 10 millimeters that surround the cover. And then pull this motor out. Alright, go ahead and pull all these bolts. I think that's all of them. Let me look real close first and make sure all the bolts are out. Alright, let's give this thing a few whacks with a rubber mallet, see if this thing will come loose. Pretty sure I got all the bolts out. I don't think they have any pry points. Pretty sure that's all the bolts. Gotta find somewhere on here that I can knock this thing loose. There's a little ledge right there. I'm going to use my punch. Oops, the oil filter spring fell out. Make sure we keep that. It's starting to come loose. Boy, they don't make this easy. Oh, stuff just fell out. Great. Well, you can't see in there. You can't get your head in there to look at nothing. They don't give you nothing to pry against. Good job, Honda. There's a place down here on the bottom. There we go. So now the oil's coming out. We'll let that drain into this bucket, and we'll see here in just a minute if I got to take that drive shaft out or not. Now, the manual says you got to unbolt the front diff and push it forward to get this apart. So hopefully we can get this cover off without having to go through all of that nonsense. Yeah, whenever I work on something that's got a transverse mounted engine like this Foreman here, you know, there's the 250 ES, I believe, is that way. The Rancher's that way. The Honda Goldwing, the Honda CX500. There's a lot of machines, bikes, quads, whatever, that have the engine in here sideways. And whenever I see that, I know that working on it is going to be quite difficult. Because normally the engine's sitting in here this way, and this cover would be right here. you know, really easy to get to. So we're getting there. I don't have a lot of experiments. We'll see what's inside this cover one way or another. Alright, will this cover come off without taking off the front drive shaft? Okay, there's these little shifter gears in here. I'm going to go ahead and pull those out. These two little gears here. That way they don't fall. Now there's the clutch play adjuster mechanism. That still may fall out when I pull this cover off. And will it come off? I mean, you only need the slightest little bit of movement in that shaft coupler. Of course, all these parts fall out everywhere. So I think I can get this out of here without taking the drive shaft out. We've got a seal that fell out here. There's this little spring that fell out. Or no, that's the ball cam for that. So that goes right there. This little guy goes on there. Now this shaft seal fell out. I'll have to figure out where that came off of. And then there's this arm. I'll show you once I get all this apart. Let me go around the other side, see if I can't wiggle that cover out of there. And here's this lever on that shaft right here. This is what actuates this. When you shift gears, it actually depresses on the clutch and releases the clutch plates. That whole mechanism. But yeah, you can't actually get that cover off without taking the drive shaft out. It's really tight. So there's quite a bit of sludge in here from the clutch, or from old oil, one of the two. I'm guessing it's from the clutch since it's right here in the clutch cover. But that seal that fell out, it goes on the other side. It goes in here. Can you see that? I'm going to dump oil everywhere. It goes in there. But they basically designed these to where you have to remove the engine to really work on it. And I don't like that design. To me, that's bad engineering. But anyway, enough of me complaining and whining. Let me pop this. Can you see what I'm pointing at? Inspection cover off, and we'll get this thing on top dead center on the compression stroke, and we'll see if our camshaft marks line up, because that's what all this effort was for, just to get in there and look and see if that camshaft's lined up. I really hope it jumped time, because this was an awful lot of work just to go in here and just have a look. Alright, so I gotta go get a flashlight. I'm going to use the pull rope. I'm sure if I pulled this pull cover off, there'd be something I can get an actual wrench on, or I can get a wrench on the crank out here. And I can turn this over to the T mark is in the hole, lined up in the center on the compression stroke. Alright, so I'm just going to use the clutch bolt here to crank the engine over. And I'm going to stick my finger in the spark plug hole, and I'm going to feel for compression, which is, I think I'm on compression, so we'll go ahead and go all the way around here. Alright, there's compression stroke. Now I'm going to look for the T mark to show up in the hole. Alright, T mark is in the center of the hole right there. See it? Alright, let's look in here and see if the marks are lined up. So there's a little triangle notch on the top there on the case above the cam sprocket, and then there's a punch mark on the sprocket itself. I'm trying to get the light in there, but yeah, it looks like it is off one tooth. Sure, my camera keeps fogging up, but yeah. So what caused it to jump time? I don't know. The chain's still tight. The timing chain guides don't look like they have any wear on them. The only thing I can figure is the chain tensioner let loose, but somehow, you know, stayed tight. I don't know. But I think what I'm going to do here is I'm going to replace the timing chain tensioner, and to do that I got to take the cylinder and cylinder head off. But I think I'm going to leave the chain and the guides alone, since they don't look like they have any wear on them. So it kind of sucks. That the chain tensioner is right here under the cylinder, and there's no way to get that out of there without taking the cylinder and cylinder head off. If they'd have made this so I could take the timing chain tensioner out without taking all that off, then it would just be one part. But since I got to take the top end apart, I'm going to go ahead and look at that. Hopefully there's no damage in there, and probably go ahead and replace the rings and of course the gaskets, because while we're there might as well put rings in it. So I need this gasket, I need a timing chain tensioner, and the top end gaskets and a set of rings. Alright, so I got the top end off. There was one casualty. This bolt was seized into the case and I broke the head off of it. The timing chain tensioner is at its limit, so the chain is worn out. So sorry I didn't film none of this, but this is basic stuff. You just pull off the nuts and lift this off of here. Nothing to it really. And I was just checking the ring and gap here. I know you need to center this with the piston, but yeah, the rings are completely shot, so it's probably a good thing we're coming in here. We had to come in here anyway, so yeah, so that's a pretty big gap on the rings, so it does need rings. The piston looks okay, but look what else I found. That is a helicoil sticking down into the combustion chamber. So somebody's done a thread repair on this, and they did not, I would say, do a stellar job on that. So that issue needs to be addressed. So not only did it jump time, more than likely because the chain's worn out. Yeah, it needs rings and thread repair, and I gotta fix that broken bolt. Oh wow, Honda. All that you gotta go through to repair one of these. Now I don't know how many miles or hours are on this machine. If I had to guess, I'd say there's a lot just in the condition of it. So it's had a rough life, but you know, here we are. Alright, I gotta get the timing chain out. And in order to do that, I gotta remove this. I gotta remove that. To remove this, see if I can get you in there. That nut is staked onto the shaft, and I gotta bend that staking back, get that nut off of there. Alright, so the Honda manual says to unstake this nut. Although they don't give you any suggestions on how you might do that. I tried to stick a pick in there and kind of bend that back up out of the way, and it just broke the pick right off. So I don't know how they expect you to do that, but what I ended up doing is I got my impact in there and just spun it off with that, and it seemed to come right off. So I wouldn't struggle too much about trying to unstake that. I would just get an impact in there. It was kind of, I have an air impact. I kind of snuck it up under the frame right here and used a short extension. Let me show you. So I just stuck my impact up underneath the frame there and got on that nut like that and zipped it right off. Is that the right way? Probably not, because you have to have a special tool to hold the clutch and everything, and yeah. So this is the tool I'm using to get this off of here. I don't think it's going to be very tight. If you don't have a special tool, you can tap this off with a hammer. So just some light taps, and you rotate it, tap, rotate, you know, and it will eventually pop off of there. It's not on real tight. All right, I gotta take this clutch off. There's 4 bolts, 10mm. Do a little bit at each time in a crisscross pattern so you don't warp the pressure plate. There's a washer behind that nut. Don't lose it, and you can slide this clutch right out. A little spacer behind there. You can leave that, because I'm not changing the tensioner. I should be able to slide this gear off. There's a washer behind it. Then pull the cam chain tensioner out. Probably should have loosened those sprocket bolts before I took all that apart. Alright, before you take this cam chain off, line your T-mark up in that hole, and then you can take the chain off. And don't move the crankshaft until you get all this back together and in time. Yes, definitely loosen up these 2 bolts before you take any of this other stuff off. That way you have something, you know, you have some resistance, because these bolts are in there pretty tight. So don't make the same mistake I did. So I'm just comparing the lengths of the chains, making sure they're correct. That's the part number. So we'll get that new chain in. But before I do that, since I'm at the point where I'm done taking things apart, I need to scrape all the gasket surfaces clean and get all this cleaned up, and then I can start putting parts back in the engine. I'm gonna try to get that broken bolt out. It's not really a very important bolt, but they did put it in there for a reason. So I'm gonna try to heat this up and twist it out of there. If I can't, I'm just gonna leave it alone. Yep, it just broke right back off again. That's the bad thing about aluminum. Once you get corrosion in there, it will never let go of that bolt, and you'll just have to drill it. That's out of the scope for this video. I'm going to leave that alone, make a judgment call. I know you guys are screaming, "No, you got to replace that bolt." Well, I'm not. Alright, this helicoil issue. I'm going to try to just stuff that back in a thread, see if that will fix it. Otherwise I'll just have to go get another helicoil. But let's see what I can do here. I don't really see helicoils fail like this. A lot of people like to use time certs for spark plug holes. Just been in my hemostats. I'm going to have to get something stiffer than that. Yeah, my efforts here may be futile, but yeah, it's all warped out of shape. It's not gonna fix it like that. Alright, let me see if I can get this out of here. Yeah, that was a screw up there. So I'll have to go get another coil. Luckily it's already tapped and everything, so I just need the coil. Alright, so these helicoils are not available in my town. I had to order them in another town, so in the morning I'll have to go pick these helicoil up. So this will have to wait till tomorrow. Alright, so I went ahead and installed the chain. I'm going to make sure those dots are lined up with that arrow in there. Like so. And that's with the T mark lined up in this hole. I'm going to go ahead and install the chain tensioner gasket. That's the part number for it. And the chain tensioner. And that's the part number for it. Now the new tensioner does not come with that Phillips screw that goes on the top of this, so make sure you keep that out of your old tensioner. We'll go ahead and install this now. And if I didn't mention it, the cam sprocket bolts get torqued to 14 foot-pounds, and make sure you use Loctite on those. We'll set our gasket on there, and we'll put our new chain tensioner in here. And the new tensioner comes with this plastic piece, so that when you get this installed, you just pull this out and that sets the tension. But if you're going to reuse your old tensioner and you don't have this little plastic part, then you're going to use a small flathead screwdriver, and you'll stick it in there and you'll twist, and that'll draw this up. You'll put it in here and turn this clockwise, and it'll draw this plunger in like so. And then you would hold this, and then you would install it, tighten up the bolts, and then let that go. Alright, so the old tensioner was almost completely fully extended. You can see how this one's a little bit less than halfway through its travel. So that old chain was definitely worn out, and probably the reason why this jumped time. I'm going to take some oil and I'm going to lube this chain down with some fresh motor oil. Just so it don't start up dry. Alright, going back on with the clutch, there's a washer that goes behind the nut. So we'll slip this on. Wait. So we're going to install this gear onto the crankshaft. Like that. And then we're going to put the clutch on. Get the splines lined up, and then there's a washer and the nut. It's not the right nut, is it? Yeah, it is. They're both staked in. I don't know why they do that. So we just got to torque that nut down next. I apologize, this is kind of dark in here for the camera, but there is a notch in that shaft. And I'm just going to take a punch, and I'm going to stake that nut down into that notch. And we can put our clutch springs back in, and then the spring retainer. This is marked out, so don't flip this thing upside down. And just like we did when we took it apart, I'm going to tighten these a little bit at each time, crisscrossing back and forth. Slip the centrifugal clutch back on. You'll line up both sets of splines. Now get yourself a deep socket. In this case I'm using a 1-inch, and set it over that and tap this in place till it fully seats. Get that seated. And then there's a washer and the nut. And again, tighten this down and then stake that nut into the dimple on the shaft. Alright, there's this ring that goes in the clutch right there. seat that all the way in. And then there is the adjuster mechanism. The bearing will sit in that ring. Seat that all the way in. And then there's this lever arm that goes on this shaft down here, and the shaft is splined and it's keyed so it can only go in one way, and then you slip that in that fork of that right there like that. And then there's the washer that goes on the outside down on this shaft behind that lever. Now there's this ball cam here that goes on like that. This ball cam has a spring on it. Make sure the spring goes in towards the clutch, like so. And that'll just kind of sit there. Now if you remember earlier, I talked about a seal that popped out. This seal here, it goes in the case right here. This is where the shifter shaft comes through. This is where the shifter shaft comes through. This is the electronic mechanism that shifts the gears. So I got a new seal for that. There was 2 part numbers. So when I asked the Honda dealer for this number here, you see that? That's hard to see. So when I asked the dealer for this number here, he couldn't find it. When we looked up this number, he found this with the original number written on the bag. So for whatever reason, there's 2 part numbers for this. Alright, so we're trying to keep the oil in, and you always want to put the cup side with the spring towards the side you want to keep the oil in on. So I'm going to set it in with the spring side down. Pop this thing into place here. And go get something to drive that down with. It's a 12mm socket here. Alright, that's installed. Now I know some people are going to be upset that I didn't replace this gasket, these O-rings, and all these other little O-rings, but just experience will tell you if these are going to leak or not. If you rub your finger over this and you feel this O-ring stick up above the surfaces, they're fine. There's no need to replace them. If you want to be extremely cautious, then by all means replace all the O-rings and seals and everything. But I know this isn't going to leak. I am absolutely fine with reusing some of these gaskets. Alright, here's the gasket for that cover. There's the part number. Go ahead and open this thing up. It's on there right like that, but I'm going to put it on the engine case, because the engine case still has the dowels in it. That'll line this up and hold it in place. So let's go over to the engine. You just hang it on the dowels like that, and that'll hold it in place for you. Alright, quick double check, make sure everything's in place. Got everything installed. Just gotta be careful you don't bump these parts off when you go to set this cover in place. I know you can't see it, but that shifter shaft is sitting right here. And you're gonna line it up with the hole in this case. So aim for that first. That started on there, and with that front drive shaft in place, you gotta really wiggle this thing in just right. The gasket's falling off on me. Make sure that gasket stays in place there. There, that's on. Now you can put all the bolts back in this, and we can get ready to put the shifter motor back in. Alright, now we have the electric shifter mechanism gears. Ooh, these are dirty, hold on. So that one goes in there. This one has a punch mark on it. See that punch mark? Make sure that goes out. This is going to slide on that shaft, and it's keyed so it can only go on one way. So you can't put it on wrong. So find the key mark. Slip that in place. And the other gear is still on the motor there. So we're going to slip the motor back on. Before I do that, before I put that motor on, I'm just going to put a little bit of oil on these gears. And we can slip the motor in place. Gonna mesh them gears and get all the shafts lined up. Wiggle it into place, just like that. And there's this cover that protects that electrical connector. I'm gonna put it back in place. And there's one bolt with an 8mm head. It goes down on the bottom here. We can get all those tightened up. Alright, I got the brand new oil filter. There's the part number. Spring goes in first. And then the filter with the rubber bit goes out. It even says on the filter, outside. Clean the cap out real good. And line up this hole with that O-ring. So I want to stick this through that O-ring first, and then I can set it in there. That makes it a little easier. Now, just in case you were wondering why this one bolt is shiny, well, we're not going to talk about that. Alright, so it's the next day. I got the helicoils in, and the temperature outside went from 60 to 35 like it saw a state trooper. So I got my heater running. Sorry about the noise in the background. So we just got to get one of these installed here. I went ahead and took a tap and run it through those threads to clean those threads up. And if you're curious, this helicoil is for an M12 1.25 pitch spark plug. So I need to get an install tool and get this thing put in. So normally if you're doing a thread repair with a helicoil, you'd have a specific size drill bit and a specific tap. Since this has already been tapped and drilled, shine some more light on the subject there. Just going to run this in to where it's just below the surface. Alright, right away I see that the reason why this thing has messed up is it's doing exactly the same thing it did before. It jumped a thread down in there. So that's no good. We don't want that. So I'm going to twist this thing all the way back through and try again here. For some reason this helicoil is not doing the thing. Huh. Alright, let's try again here. Yes, he's doing it again right away. Huh. I've installed many helicoils. I've never had this issue before. Alright, let's try another new one. This pack of coils was $11. I don't want to go wasting these things. So it's already jumped a thread. And this is where frustration sets in. So just when you think things will be simple, they are not. So what had happened is whoever tapped this for the helicoil cross-threaded the tap in first, so there's two starting points for the threads, and I had to find the correct starting point, which I went through not one, but where'd the other one go? Not one, but two wasted helicoils to find the correct thread starting point to get that thing in there started. Sometimes you just never know what you're going to struggle with. Alright, so I just got to break the tang off on the inside here. Okay, that looks good. Fixed. Jeez. Alright, so I need to measure the piston to bore clearance. I don't have a bore gauge, so I'm going to use my snap gauges and my micrometer. So the wear limit is 3 inches, 547 thousandths. We're close to that, but it's still in the service limit. So now measure the piston. So it looks like we got 1, 2, 3, call it 3.5 thou clearance between the piston and the cylinder, which is within the service limit. And I need to check the ring gap. The bottom ring is going to have a bigger gap than the top ring. So this is the bottom ring. Square it up with the piston. So the service limit for the bottom ring is 20 thousandths. So we're right there. And then the top ring, and again the service limit is 20 thousandths, and we are well within that. Okay, so this should seal up well. I went ahead and did a light hone job to the cylinder. The cylinder looks pretty good considering the condition that this ATV's in, and the piston shows very minimum wear. So the top end is good to go, just needs a set of rings. Now the old rings, I could measure the gap. The old rings I can measure the gap with a ruler, so it definitely needed the rings. I'll go ahead and get the piston re-ringed and get it back on the machine, and we can start stacking these parts on. Alright, so when you're installing your piston rings, this is the spacer for the oil control ring. You do not want to overlap these coils or these waves. They butt together. If they're overlapped, that's wrong. So I'm going to start by putting the waffle layer in. I'll put its ring gap there. And then I want to put the bottom rail in. With its ring gap over here, and the top rail in with its ring gap over here. So that they're staggered here, here, and here, like so. Now the bottom ring, if you notice, I don't know if you can see this in the video or not, but one ring is silver on the outside edge and the other one isn't. The silver one is your top ring. The other one is your second ring. And if you look, there's a T mark that stands for, that needs to go up. So my oil control rings are spaced over here, so I'm going to put my compression rings gapped over here. You can walk them on with your fingers like this, or you can use a ring spreader, whichever you prefer. I'm going to gap these. The top ring has a mark on it too, indicating up. I'm going to gap these 180 degrees apart. Now, don't get too obsessed with the spacing of these gaps, because after this engine runs, these rings are going to rotate around the piston and it's not going to matter anyway. The gap is just, the spacing of the gaps is just so that you get the best compression for startup, because you're going to have the least amount of compression because you know everything needs to, you know, work in together. So I got my piston ringed in. We'll go ahead and go over here to the engine and we'll reinstall this piston. Now I'm just going to take and put a little bit of oil in the wrist pin bore and rotate my crank so that the rod is all the way up. And I'm going to put some oil in the small end of the connecting rod. The piston is marked with IN. That goes towards the intake. And sometimes it helps to slip an extension through the other end of your piston and use it to line up the connecting rod, like so. Now, before I put this circlip in, I always like to, especially on these 4-strokes, put a rag underneath here so that I don't drop that stupid clip down in the motor and I gotta go searching for it. So I'll get this wrapped around here the best I can so that it cannot fall in the motor. Now the opening on this clip, it either needs to be up or down. You don't want it sideways, because the idea there is that the inertia of this moving up and down could squeeze this gap together and the clip could fly out. An engine that don't rev very high probably wouldn't have an issue with that, but that's just something to be aware of. So I'm just using my fingers here to insert this clip and make sure it snaps into that groove in there. So get your flashlight out and look real close and make sure it's snapped into that groove. Normally you can hear it, but sometimes you can't. Like that one, I didn't hear it, so I gotta grab my flashlight, wherever that thing's at. Let me search for my flashlight for 15 hours. There's one tool in this shop that I have trouble finding all the time. That is my flashlight. So I got the gap to the clip, the wrist pin clip down, and it is fully seated. And there's the piston installed. So I want to get some oil on these rings. Not so much it's just oozing everywhere, but get a little bit of oil on them. Down in the grooves. That way nothing starts up dry. Smear this around, wiggle your rings back and forth, spread that oil around. Rub down the piston. Alright, here's the new cylinder base gasket. There's the part number. Alright, I put a light coat of oil in the cylinder. And this thing is quite tight fit in past the frame. I'm going to kind of try to wiggle this thing in here. fun part is getting these rings compressed, getting that piston slipped up into the bore there. There is a bit of a chamfer on the bottom of this to help guide everything in. But just got to be careful you don't break a ring during this process. This can be very fiddly, so take your time. Don't force anything. Once you get those rings compressed to the point to where they'll slip inside that chamfer, it will kind of just slide together. Sometimes you got to pick back up on it, start over, reposition, regroup. Don't panic! This is exceptionally difficult with the engine in the frame. I've slipped these right together and I've struggled. It's just, you got to be patient. You don't want to break a brand new set of rings. Of course, this is more difficult too because I have the camera running, so I'm under pressure to perform here. But this is real life. This is how it goes sometimes. It's never always easy. And really, I want to be over there where you guys are at. Okay, let's regroup here. Okay, I gotta stop, take a break. Man, I have never struggled so much putting a piston in a cylinder in my life. Jeez. I don't know if it's because of what machine it is or I don't know, but wow, that was a struggle. So you haven't fully lived until you've recorded yourself struggle on something you've done 1,000 times and trying not to get upset and cuss and yell on camera, and on top of just, you know, the ordinary stress of being a mechanic, you know, filming the whole process while you're doing it. Start a YouTube channel, they said. Yeah, it'd be fun, they said. Alright, I'm going to drop the push rods in. If you're reusing these, make sure you orient them back in the exact same position they came out of. As in, the top of this one's still at the top of this one, and so on. So what we need to do here, since I've cranked the engine over a couple times, I'm not sure where I'm at. I need to find top dead center. So I'm just going to grab the pull start, and I'm going to feel for the valves to open and close. So there's the exhaust valve opening, there's the intake valve opening. Now it's coming up. This is the compression stroke right here, and we want to get it on top dead center, and that's where we want to put the head on, like that. Alright, brand new head gasket. There's the part number, and we've got to figure out which way this goes on. Let's see, can it go on the other way? Looks like it can go on either. No, it can't. Okay, so it can only go on one way. That's nice. So it's got some stamped numbers right there. That's facing up. So let's go grab the head. Slip this in here. There we go. And we can install the push rods. Make sure they seat down in those buckets. I mean, you can't really screw that up, but you know, just make sure you push down and feel that they are actually seated. And we got the rocker box. Slip that on. And put some oil on the threads. And I think it's pretty obvious that the clean ones go inside the valve cover. So we'll find the 3 clean washers, put those on, and then the 3 clean nuts, and we'll put these on. Well, I tell you what, this project is, it's really been dragging out. That's not the right one. It's kind of kicking my ass, to be honest. When this quad came to me for repair, I was totally expecting it just to be a dirty carburetor and clean the carburetor and be on with my life, but so far this has been a huge endeavor. And like I said before, I don't have hardly any experience on digging into one of these engines. Because I mean, honestly, they run for so long without any maintenance that, you know, you really don't ever work on one of these things. And that's a good thing too, because this thing is a pain in my ass. Alright, they want to torque these to 29 foot-pounds, but you need to do it in 3 steps. So I'm going to start at 10, and like always, crisscross. And I think I'm going to jump it up to about 15, and I'm going to recheck them. And don't forget the 2 little bolts that go down the side of the head here. These get torqued to 7.5 foot-pounds. Alright, so they want 6/1000ths on both the intake and the exhaust. So we'll go ahead and set that. Here's my 6 thou feeler gauge. So this one's wanting to loosen the gap as I tighten the nut, so I got to make this a little tight. And then tighten that jam nut. A little too tight. Back it off just a smidge. There we go. A little tight. Back it off a smidge. Right, there we go. And finally, the last new part, valve cover gasket. And there's the part number. Alright, get these tight, that'll be the end of the torment for me. Alright, so there's just a few things to button up here. I gotta put the exhaust back on, that engine mount needs to be tightened back down, carburetor's gotta go back on, and of course, you know, all the plastic pieces. So I'm gonna go ahead and get all this back together, because that's all basic stuff. You guys don't need to watch me do all that. And then we'll see if this thing will start up and run. Alright, let's go ahead and get a compression test real quick here. Throttle wide open, crank. And it's 50 pounds. That's no good. Battery's weak. Let me charge the battery up. God damn it. Alright, so the battery was a little weak, so I got the battery charger on it, but I ended up using the pull start, and we have significantly higher compression. So Manuel says you need to have anywhere from 78 to 121 psi with the decompressor activated. And we were only getting about 80 before, which was in range, but obviously it was low. So my assumption that it has a low compression problem was definitely, you know, that was true, you know, especially when we looked at the ring gap of the old rings. All right, the oil's in. I got fuel source up there via IV bottle. Spark plug's in, exhaust is on. Everything looks like it's plugged in. The battery charged for a little bit. Let's see if this thing will run. Hold choke. Key on. Alright, here we go. Still doing the exact same thing. Are you kidding me? Still running the exact same way. I give up. The camera lens is fogging up. Alright, so I got this thing to start. It would only idle. I could not give it no throttle. I tried to get this on camera, but the footage got corrupted. So I'm trying to figure out why it won't take no throttle. I pulled the carburetor off a couple more times and went through it. And in the process of doing that, I lost all spark. So that led me down another rabbit hole on why I didn't have spark. So the manual suggests that you use what's called as a peak voltage adapter that you plug into your multimeter to test the pickup coil and the ignition coil and, you know, the ignition system. Well, I don't have a such device, so I had to put one together. And it looks like this, and it's just a capacitor, a resistor, and a diode, and it just takes the AC pulse, on-off pulse, turns it into DC, and captures the peak voltage that your multimeter can detect. And so I did that, and I determined that the pickup coil or pulse generator, or whatever you want to call this, crank position sensor, that's not really the right term, but this guy right here is going bad. So, okay, let's back up. In my process of figuring out why I lost spark, now on these machines, the CDI box, or in this case it's called an ignition control module, this box here, needs to see a signal from the stator, and the regulator rectifier has to be in the circuit and working in order for the ICM to put out a spark. So one of the first things I checked was see if this guy was working. And when I looked in here, this has been replaced. So I disconnected these wires and looked inside here, and I could tell that somebody had been in there with a probe because all the pins were bent up and some of them were not making contact. So I pulled that connector apart, straightened out those pins, and got spark back. I thought, okay, good. Now we're sparking again. I tried to start it up again, and it would only idle. That's what sent me down the rabbit hole of testing the ignition coil, the CDI box, and that pulse generator. And my conclusion here is that this quad has multiple problems, and that's probably why two other mechanics before me could not figure out why this thing was going on, because it has so much wrong with it. So I got a new pickup coil. I'm gonna take this thing over to the bench. Sorry I didn't film taking this thing apart, but it's pretty straightforward. You just got to take the recoil starter off. and there's a row of bolts, and then, you know, it's not, this isn't that big of a deal to take off. But this guy right here, I want to do a continuity check on this, because this is supposed to have around 300 ohms of continuity, and I'm not getting any continuity through this guy. Even though it was trying to generate a spark and the machine was kind of running, this part is actually bad, so we're going to replace this, and hopefully the machine will run after that. Alright, so here's the new part. This is where the wire connects and it grounds to the, you know, to the mounting flange here. So I'm going to take my multimeter and I'm going to put my black lead on the base and my red lead on that pin. And you can clearly see we have 314 ohms of resistance. Now if I do that with the part that's in the machine, you can see we're getting 2.6 kilo ohms. That's way too much. So this part is trying to spark, but it's not sending out a strong enough signal for the engine to run. Now this is my theory at this point, because the engine will kind of run. So this is my best guess here. Because if the ignition system's sparking, then everything should be correct, right? I mean, you should. It's either it works or it don't work. This is a very. This is the exception, not the rule, because it's rare that you have an electronic ignition system like this that kind of half works or doesn't work well. It either works or it don't work. Now I tested the stator, and that checked out fine, and you can just look at the stator and say that that's in good condition because it looks brand new. So we're going to replace this and hopefully it'll run after that. Now you can test this with it still mounted in the machine. So this is the stator connector. It's this round 5-pin plug. You want to find the blue wire with the yellow trace and the white wire with the light green trace. The blue wire is this wire here that goes to your pickup coil. That's the blue wire with the yellow trace. The white wire with the green trace, that's the ground. So you would probe for continuity. So you would probe for continuity between these two pins right here, like so. And that gives you your reading. So that's how you test the pickup coil when it's installed in the machine. Sorry I can't get you guys in here to film putting this thing in, but you just won't see anything. But I just want to give you a quick tip. This right here is the shift sensor that tells the dash what gear position you're in. And when you're installing this thing, make sure that you're physically in neutral, plug the connectors back in, turn your key on, and you're going to twist this. You're going to twist this little T-shaped thing, and you're going to make sure that you're in neutral. And that'll line that up when you go to install this. Alright, look right here, see if we got spark. Alright, it looks like a good strong spark, but we're not out of the woods yet. And the reason I say that is because this thing has multiple issues. You know, in order to check the rest of the system, that pickup coil had to be in good shape to get good readings on the rest of the ignition system. So I messed with the connector there, and I replaced that because spark was coming and going on me. So now let me get my gas hooked back up to the carburetor, and we'll see if it'll run this time. Alright, this is starting attempt, I don't know, 4, 5, 10, 82, I don't know. So pull the choke, turn on the key, I'm going to hit the primer button once. There we go. this we have nothing. Oh, this thing is wearing me thin. Got a good hot spark. Hold on, I got a fuel leak. I gotta fix that. So I got spark, I got fuel, I got compression, I got timing. That don't sound right. What does that sound now? Oh, great. Alright, let's see if it'll run. Well, it'll idle. Won't take any throttle though. Yeah, it won't take any throttle. Yeah, anything above a certain RPM and it will not run. Alright, so I'm just checking the peak voltage of the CDI box here, and I got it connected to the primary wire of the ignition coil, and I got my peak voltage meter in line here, and the book says we should have anything over 100 is good. So that tests out, but no matter what I do, if I give it any throttle, it dies out. So need to continue with testing here. I'm not sure. I wonder if it's a regulator rectifier, because this thing's hooked up to the charging circuit. If it's not, I don't know. Let me do some more investigating, because so far everything's checking out now that I replaced that pickup coil. So hold on, let me do some more digging. So continue on with testing. I tested the stator output as much as I can. The manual wants you to rev the engine up, but I cannot do that, so I can only test it at idle. But each leg of the three-phase alternator is putting out 11 volts at a very slow idle. There's no shorts to ground. Continuity is consistent between all three wires. I don't think the stator is the problem. I did find where someone has been testing previously and had probed the pins and had messed up the pins in the regulator rectifier connector, which in this machine, if this is not functional, you won't have any spark. So I depinned that, fixed all the pins in that. Okay. You would think, oh, it'll run. No. So I've done a coil test with my spark tester. The spark will jump a 14 millimeter gap hooked to the spark plug and still run. Plenty of coil voltage, plenty of spark. It's not a spark problem. Moving on up here, I have checked everything to check up here. I have my trigger pulse, I have my AC generator wire right there from the stator. That's got good electricity flowing through it. I have tested my kill switch. I've even bypassed the kill switch. That does nothing to change how it runs. Got grounds. I cleaned the frame ground there. I cleaned the engine grounds there. I cleaned the frame ground there. I have done peak voltage testing on the pulse trigger. I have done peak test voltage on the CDI box. That all passed the test. I have replaced the CDI box with a known good unit off of my friend's Foreman. That did nothing to change. I have another CDI box here. That did nothing to change the situation. I also replaced the voltage regulator rectifier. I borrowed it off of my friend's running and driving Foreman. That did nothing to change the situation. The compression is now reading well over 100. It has good compression. I did a leak down test. That passed. I removed the exhaust, checked the exhaust for obstructions. I put a timing light on the spark plug and removed the inspection hole right here to see if spark was happening at the right time. It is. So the spark timing is correct, cam timing is correct, compression is correct, the wiring is correct, the stator is correct. What is the problem? Now I know what you're thinking. It's the carburetor. And I know why you're thinking that. Because that's what I was thinking. It's got to be the carburetor. After everything that I've tested, everything that I had checked, it's got to be the carburetor. Now I've worked on enough things and I have fixed enough things to know when it's a carburetor problem. And this is screaming carburetor problem. So what did I do? I put a different carburetor on it. It runs exactly the same way. You can put, so usually when you have a carburetor problem, if you spray gas into the carburetor or starter fluid or something, you can get the engine to fire up and you can use the throttle and it will rev up. This will not, no matter if I put fuel in the carburetor, if I put starting fluid in there, brake clean, hose it down with gasoline, no matter what, this engine will not rev any faster than that slow idle, no matter what I do. It's like the spark won't advance. Does anybody have any idea of what I can check? I have spec'd out and ohmed the wiring. I have done voltage drop tests. I have done every single test and everything that you could possibly think of to check or do in my brain in all of my 30 years of knowledge of working on these machines. I can't figure this one out. So if anybody has any suggestions, please drop me a comment. A lot of you were saying, you know, it needs the air box. And you are correct. On a CV carburetor, they don't like to run right unless you have the air box installed. But here's the thing with that. They will still run. They'll still rev up. They'll just run like crap. You know what I mean? They'll spit, sputter. They'll choke and die. But they'll still rev up and kind of run. And especially if you spray fuel directly into the carburetor, you can rev the engine up. Yeah, not having an air box on there isn't going to allow it to run correctly. But the problem is I was having was it would only run at a really low idle. Even if you turn the idle screw up, it would die. As soon as you get the carburetor out of, okay, how do I say this? The carburetor had to be adjusted to run at the idle speed, the spark advanced idle speed that whatever is going wrong with this thing wanted it to run at, if that makes sense. So if I adjusted the carburetor up too high or a mixture or whatever, you know, I had to tune the carburetor to get it to run at that RPM. This is an electrical problem. It's not a fuel delivery problem. I have the fuel running from this, for lack of a better term, IV bottle down to the carburetor. Okay, so it's not hooked up to the gas tank at all. So it's not a fuel flow problem. So as far as testing is concerned, the factory Honda Foreman manual for this is pretty vague. They want you to use a peak voltage meter and test the peak voltage coming out of the pickup coil, and test that. You want to test that in two places: back there at that connector coming out of the stator, and also up here at this connector at the CDI box. And the manual basically says if you have the same reading here at the CDI box as you do back there, then the pickup coil is fine. My testing proved that the pickup coil was bad. As far as stator output testing, the stator output test in the book is basically a continuity check and an ohms resistance check. So you want to check between each leg of the three phases of the stator to ground. There should be no continuity at all between each one of the phases and ground. That would indicate that the windings, the lacquer coated copper wire windings in the stator are burnt and melted and making contact to ground. All that tested out fine. The next test they want you to do is an ohms reading between each leg of the stator. That passed the test. And there's only one other test, and that is a voltage output, a maximum voltage output test of the stator, and they want the engine running at 5,000 RPMs, and they give you a number to when you put your meter on there to match up with at 5,000 RPMs. Well, this thing would only run at about 600, 700 RPMs, so I could not get that maximum output voltage from the stator. The manual wants you to get a peak voltage output from the CDI box, okay? And it tells you it can't be below a minimum voltage. And you check that at the black wire with the yellow stripe here at the coil. So you go between this and ground with your peak voltage adapter, okay? Which I had to make, because I didn't want to wait to buy one and they're like 70, 80 bucks for a resistor, a capacitor, and a diode. So I just made one, but that is the test that they give you to test the CDI box. So if you're getting the proper voltage from the CDI box to the coil, it says replace the coil. Now let me be clear here, this manual is giving you testing for a no spark condition. It doesn't say anything in the manual about having a erratic spark or a spark that's not timed correctly or anything like that. These tests are strictly for no spark, and it clearly had spark. Okay, moving on. The ignition coil primary and secondary windings. Now the book does not give me any numbers to match up the primary and secondary windings of the coil. Now I can test that and I can get a number, but compared to what? There's no numbers in the manual to compare those two. It basically says if you have no spark and you have the voltage coming out of the CDI box, the coil's probably bad, and replace it with a known good part. The problem with dealership manuals is at the dealership, they have all these parts on hand on a shelf. They can just walk over and grab one and try it on there real quick. So troubleshooting with a factory manual can be problematic, to say the least. How I test coils is with a spark gap test. This is my spark gap tester that I made. I got this design out of a repair manual for a vintage motorcycle. It's easy enough to build. This is wood. This has got a 14 millimeter, I believe it's 14 millimeter, I can't remember, but it's got a big hole in it, so it's got to be able to jump that gap. Now this is adjustable, so I can move that spike in and out to adjust the amount of gap. Now it takes 10,000 volts to jump 1 centimeter. That's 10 millimeters, or about 3/8 of an inch. Most motorcycle coils are going to produce anywhere from 20 to 30,000 volts, so 3 centimeters. Now if the spark will jump across this gap, even if I open this, hold on. Even if I open that gap all the way up on this machine, it will throw a spark all the way across there, and if I clip that clip right on a spark plug and run this in series, it'll jump that gap and also jump the gap on the spark plug in a compressed cylinder and still run the engine. Now this is how I test spark. If spark won't jump across this gap, you have a bad coil. This coil is good enough to jump the gap on this with it wide open all the way like that, and hook to the spark plug and still run the engine. So lack of the numbers that I need to do a resistance check of the coil, this is how I do a coil test. Now going back to explain how a coil works, it either works or it doesn't. It either jumps that gap or it won't, or it'll be weak. And you'll know right away with a tool like this. Now if you have one of those tools that where it just lights a light, that's not as good as a tool that actually jumps a spark gap. Now there is a manufactured tool that you can buy. There's also a manufactured tool that you can buy. It has numbers in it and a gauge, and you can adjust the gap right there. It just happens to have this kind of end on it, and the one I made has this kind of end on it, which is what is usually on ATVs, and this is usually what's on automobiles. So this is for a car, this is for an ATV or a motorcycle. Now I understand some ATV motorcycles have that kind of an end, but not all. So I have both. Because this is the first time I've ever come across this kind of an issue, where I've replaced the pickup coil, the CDI box, and not every machine needs the regulator rectifier to run, but this one does, so that's also been replaced. Everything's been tested. The rings have been replaced, the timing chain's been replaced. It has good compression. The carburetor is functioning. Even though it acts like a carburetor problem, it is functioning. The cylinder is sealed, the valves are sealed. Spark is happening at the correct time. I've checked that with a timing light. The valve timing is correct. I've changed the timing chain, the tensioner, and reset the valve timing. It is correct. That only leaves electrical. So, at this point, the ATV will only start up and run at a very low idle. That's it. If you give it any gas whatsoever, it'll stop. It'll just die. Sorry, my camera battery died there, but I have these two CDI boxes. These both run exactly the same. I also had borrowed a CDI box off of my friend's Foreman ES 450, exact same quad, except his is a different color, but it's the exact same machine. And also the regulator rectifier. That's also been checked with a known good part. Runs exactly the same. I have swapped this out with a completely different style carburetor. A mechanical carburetor, not a diaphragm slide CV carburetor. Runs exactly the same. No matter what I've done, what I've replaced has not changed the way this thing runs at all. The only thing that hasn't been replaced is the stator and the ignition coil. I don't like to just unload the parts cannon on things. I want to know why it doesn't run, and I don't want to buy everything to fix it. I want to know what's wrong with it. Could be that it's the stator, even though it passes all the tests. Could be the stator. Not sure. Alright, so in my desperation, I had purchased 2 parts, Chinese, from Amazon. Now I know what you're thinking. I think the same thing. Amazon parts are trash, can't trust them. I completely agree. But these parts from Honda are not tens of dollars. They're hundreds of dollars. Okay? These were tens of dollars. So I purchased a regulator rectifier and a CDI box from China, and I installed them on this machine. Now, first thing, I swapped the regulator rectifier out, no change. So then I went to the CDI box, swapped that out, something changed. Let me show you the way it's running now. Okay, everything is exactly the way it was. All I've done different was installed a Chinese CDI box. We're in the neutral here. Seems like it runs just fine, but check this out. Sounds like it's got a rev limiter, right? I'm going to turn the kill switch off and back on real quick. Okay, in case it wasn't clear what was going on there on the video, it'll rev up and run now. Same setup, same fuel setup, factory carburetor, no air box. But it acts like it's got a rev limiter, and if you turn the ignition on and off real quick, you can either use the key or the kill switch, doesn't matter. If you turn it on and off, it runs perfect. And about 5 seconds or so later, it'll start acting like it's got a rev limiter. But I'm going to call this progress because now I know it has nothing to do with the engine. It is absolutely an electrical problem. And if you know these Hondas, these Foremans, you know that they have an AC signal, that yellow wire. They have to have that coming from the regulator rectifier. Now, with this particular CDI box, that's unplugged. It should not run. It should not create any spark with that unplugged with a factory CDI box. So, with that Chinese CDI box, it's looking like it does not need this AC signal wire. It could possibly be that the stator is bad. I don't know that for sure. I could buy a stator. I'd want to buy a Honda one. And again, hundreds of dollars on a guess. Or I could buy a cheap Chinese one and stick it in there and see if it'll run. Well, I did it. I unloaded the parts cannon. Alright, so in this little box I have a Chinese stator, a Chinese regulator rectifier, a Chinese spark plug, a Chinese CDI box, and a Chinese ignition coil. And also in this box with the stator there's a Chinese pickup coil or pulse generator coil. Which one of these parts is going to make this thing run? So just to be absolutely sure it's not the wiring, what I did is I took a piece of wire, I put a female connector pin on the end of this wire, and I individually depinned each wire on this CDI box and ran this wire to corresponding, let's say, to the ground or to positive side of the battery or so on and so forth, to rule out any wiring problems in this harness. This proved that it's not a bad wire. So that should be ruled out, because no matter which wire I connected this wire to, it still ran the same, no change. So I think the first part I'm going to swap out, since it's the easiest part to swap out, it's going to be that ignition coil. And like I said before, I don't think there's anything wrong with that coil. So we're going to prove that right now. Spark plug wire is a lot longer on this coil. This problem is going to get into the exhaust if I leave it on there. And it's got the wrong boot on it, so I got to go get the screw-on piece to the end of that spark plug. So there's a little part that screws on the end of the spark plug. So I got to put that on for this one. Of course, you first have to drop it down in the engine before you thread it on. That's step one. Alright, see what happens. Exact same thing. It's not the ignition coil. So I'm going to put the factory one back on it. So the next easiest thing is going to be the CDI box. So let's try that. See, that runs more like the original CDI box there, where it'll barely run. this Chinese CDI box runs similar to the factory CDI box. So note that. The next easiest thing would be the regulator rectifier, but this particular CDI box don't even care if that's plugged in or not. So I guess let me plug this new CDI in and the new regulator rectifier in, see what happens. So we'll plug this in with that new CDI box, the new CDI box. And just for the record, the other new regulator rectifier was plugged in. So we'll plug in the new one. Try it again. Oh, that's running. Now we're back to this. Now we're back to, if I switch the kill switch on and off real quick, that's how it's running now. Actually, no. Seems to be running now. Okay, so it's not doing it now. It's actually running. Wow, okay. Okay, so now it's running and I don't have to turn the kill switch on and off again with the new regulator rectifier. Let me try the other new CDI box now. So let me swap this back. Of course, this, if you remember, this one doesn't care if that was even plugged in at all. See how it runs like this configuration. See, it acts like it's got a rev limiter, and if I turn it on and off again, yeah, so that CDI box doesn't run right. Let's try the OG CDI box now and see how it runs. Because before, the OG CDI box would barely allow it to idle at a very slow RPM. So let me plug this back in. It will. Why won't that plug in there? There we go. Now let's see how it runs. Now the configuration is the original CDI box and the new regulator rectifier. Okay, see, it's and that's how it was running original. Excuse me. And that's how it was running originally. It would only barely idle. And this is what I always talk about when you buy Chinese parts, the inconsistencies in them. Let me try the original regulator rectifier with the new CDI box. It's not the original factory regulator rectifier, but it was the one that was on this quad when it came to me. So we'll plug that in. We'll call this the OG regulator rectifier. stuttering a bit because I don't have the intake on it, but okay, so it's not running very good. Okay, it's running pretty poorly. Let me try the new regulator rectifier. See if that changes anything. Sorry if I'm not keeping everything in frame here. I'm kind of bouncing back and forth. So it seems to run best with the new CDI box and the new regulator rectifier. And then I say that and then it starts running bad. Well, that's the best it's ran since it's been in my shop. Wow. All right, guys. It is time to see if this thing will do the thing. Go to second here, since I'm holding the camera in my left hand. Uh-oh, the temperature light came on. Oh, I turned the gas off. That's what it is. So we need we need to have gas. Oh, this thing has been such a pain in my butt. I'll tell you what. Running. It's running, it's driving. I don't have the airbox or the seat, so I can't put the rest of it back together and kind of go for a better test ride than that. But as far as you guys are concerned, I think I'm going to end this video here because I've got, I don't know how many gigabytes of video on this thing. I'm not sure what I'm going to title this video. I guess something like, how many CDI boxes does it take to make a Honda Foreman run? But if you like this video, please give me a thumbs up. Consider subscribing, and don't be afraid to fix it. Thanks for watching. Yeah, it's still not fixed. It'll run good for, I don't know, 20 minutes or so, and then it'll start sputtering. Shut it off, start it back up, and it'll run good for a little bit, and it'll start sputtering. Shut it off, start it up, and it'll run for a little bit and start sputtering. I noticed the regulator rectifier is getting really hot. So since I have a stator, I'm going to go ahead and put a stator in it. Alright, so I put that stator in that Foreman, and well, let me put it this way. The flywheel wouldn't stay stuck on the shaft. This tapered shaft, flywheel wouldn't stay stuck on there. So it made trying to change that stator out an absolute pain in the ass. Me and the guy that owns that quad struggled trying to change that stator out for several hours. And it wasn't made quite right. It didn't quite fit in there. Ended up pulling that stator back out, putting the original one back in it. And at that point, I was done with it. I wasn't going to work on it no more. I had put, I don't know how many hours in it, 40, 50 hours of work into that four-wheeler. Replaced all kinds of parts. It was getting too expensive. I was working on it for free. I couldn't do it no more, so I sent it on. Sometimes you just got to know, when to quit. And unfortunately, that Foreman, you probably could have fixed it if you'd have went and bought Honda everything. Honda CDI, Honda stator, Honda pickup coil, Honda regulator rectifier. But that'd have been another $1,000 on an ATV that's already 25 years old. Now, if you want to do that, that's totally up to you. But I couldn't do any more work to it. That thing had stressed me out. I was working on it day and night, and all my free time I was spent trying to figure out what the heck was wrong with that quad. And I just got to the point, wasn't doing it anymore. Now, I always end every video with, don't be afraid to fix it. And I say that because anything can be fixed. It just depends on how much time, money, and effort that you want to put into it. And don't be afraid to put some time and effort into things. But when it comes down to putting extremely too much money into something, it's best just to walk away from it. Just like, for example, I'm sitting on my Players Scrambler here. This is a 1996 Players Scrambler. It's 400 two-stroke. I pulled this out of a backyard for $200. It was a complete wreck, a disaster. Everything was wrong with it. I struggled putting this quad together, but in the end, it ended up being a great machine. I ride this thing almost every weekend. I've put 1,000 miles on this thing. So don't be afraid to fix something. If it's above your knowledge, you can learn. That's why I make videos like this, so to help people learn how to fix things. But just keep in mind, sometimes you gotta call it quits. Now, I'm not trying to discourage people and saying, well, as soon as you come across something that starts to get difficult, you need to call it quits. That's not what I'm saying. When you've exhausted every resource that you have and it's still not fixed, it's probably time to call it quits. So with that being said, I'm going to end the video here. Sorry the quad's not here. It was too hard to film. It was dark. It was late at night. I was tired. I was frustrated, and I didn't want to end the video like that. So at this point, if you like this video, please give me a thumbs up. Consider subscribing, and don't be afraid to fix it. Thanks for watching.